we drive a car, do we think every detail the car has? Do we think every part? We don't, right? Instead, we just think about steering wheel, pedals, and dashboard. But the details of the car still matter. Somebody has designed them and made them work together. If we run our networks manually, we need to think way too many details in daily operations. Same may be true if we automate only partly. But instead, we can model our network and its services and let automation run the model for us. We let automation to add, delete, or modify instances of those services. When I first joined a team and started my network automation journey, there was network engineers and developers in a team. We were supporting dedicated network for media systems. So basically connecting studios to delivery systems. There were high demands for the network, bandwidth-wise, feature-wise, and scalability-wise. The team had already made the decision to automate it. They had already left behind the manual box-by-box configuration era. They had Netbox. We had data on it, and we configured our network automatically based on that data, at least partially. At that point, we started to think how to make it scale. And we identified these two problems. First one, we needed to play with way too many details in daily operations. For me, it didn't make sense that we have moved from manual box-by-box configuration to some central place, some central system, and still playing with all of the details every day. So we need to fix that. The other one was that our configuration pipeline was extremely complex. So when we took data from the netbox and pushed that to the network devices, that's what we call configuration pipeline. So basically it was running in Ansible, and Ansible was expecting to see some arbitrary tags from netbox to trigger some more configuration on the fly. And I can tell you that playbook was getting extremely complex to handle. Another problem to solve. In other words, we didn't have a good way to take data from the netbox to network devices, and we didn't have a simple way of putting data into the netbox. So for the outbound part, the solutions we came up what we call straight pipe, which basically means no modifications of data content in a pipeline whatsoever. We may still modify the format of the data, but not the content. For input part, the solution we found was higher abstraction level. And that's what this presentation is all about. So let's dig into that. This is our automation stack. So from top to bottom, we first added a layer of abstracted services on top of netbox. So basically, in our case, this layer is implemented as netbox plugin. Starting next slide, I will get way more practical, but in essence, this means that when you add an instance of an abstract service in that layer, you populate data to the next layer, lots of detailed data into the detailed state of the network, which is basically netbox is in our case. Mostly it's native models. Then we take that data from the netbox and transform it to the vendor-specific format. And then we have pipelines to transfer that data from the netbox to the network devices. And those pipelines, they are vendor-specific, so we pick up whatever works for a vendor. Now let's start to get more practical. So this is one example of a service we made abstract. This is the detailed plan of it. But the service can be anything. Like it can be brand side, if that's your business. It can be even end-to-end security policy, what we are working on in one project. Here, however, it's a virtual network. That's kind of a term we decided. It's basically a MPLS layer 3 VPN and its connections to customer sites. Anyways, in this picture, everything highlighted in green are details which needs to be correctly allocated, and they need to be correctly in place in order the service to work. So how to make it abstract? This is how we did it. We split the problem in two parts. We defined a virtual network type of, it's the service, it's the model, and then we added another model called MPLS site. And they can be connected together. So virtual network can be connected to one or multiple MPLS sites, and MPLS site can have connections from multiple virtual networks. In this diagram, you see only a couple green things users need to worry about when provisioning these services. But what in practice? It's like this. So this is the view from our netbox, our plugin, and it's specifically the form of adding a virtual network. So here you can see that we have only two mandatory parameters, name and reference to a template. So template is yet another model, just the way of offloading details from this form and make them reusable. In addition of those two parameters, I have selected to attach this virtual network to a site called Acme Site 2. And when I hit the create button, this is what got created. So on the left-hand side, you have some general details. For example, I can spot AS number. We didn't tell any AS number. But it was allocated from the AS number range of the referred template. The right-hand side is connection to customer side. And we can see there are lots of details which got created. VLANs, transit prefixes, loopback interfaces, VLAN interfaces, sub-interfaces, and actually their IP addresses and VLANs and all of those details as well. But we didn't have to think about them, but we can see every detail if we want to. Now starting from last Friday, it has been possible to see all this in visual format. Last Friday, we published a new open source plugin for Netbox called Ninja. And you can do lots of things with Ninja, not just diagrams, but you can produce diagrams like this. This is completely based on the data in the Netbox. It is rendered as you refresh the page. Here we can see our virtual network, the green box left-hand side, and its connections to MPLS side, and all of the details actually there. All of those things in the diagram, such as device names, prefixes, interface names, and such, they are clickable. So you can click and get to their respective view in the Netbox. Now we have added one instance of a virtual network to our network, but it's actually just inside the Netbox. So what's the difference between reality and Netbox? So this is our configuration pipeline. It's yet another Netbox plugin, and it can tell you that in this specific case, 500 lines of configuration will be changed. And if we click the device, for example, the router 3, we can see exact lines which are changed, which are going to be changed. And when we are happy with that, we can hit the gas and click the push button, and the change will be deployed into the production. So now I have been talking about abstraction and abstract services. So how do we design them? This is roughly the process we are following. So first, we split the problem into parts. As you saw, we had virtual networks and MPLS sites, for example. Then we design a model for each of the parts, their relationship, their fields, their references to another objects, types, and so on. And then we come up with the logic. The simple one was the AS number. It was allocated from the template, from the AS number range in the template. But there might be more complex logics as well. And these two phases, split and model, they are like usually going a little bit back and forth. First you go from top to bottom, then bottom to top, and back and forth until they match. And when we have a design, we just hand over that to the developers. They write a Python code to implement Netbox plugin or to extend our current plugin and apply all the necessary software engineering practices, such as writing tests and so on. And then we deploy into the production and take care of possible migrations. Now I wanted to take a couple of lessons learned here. There are many, but these are the top ones. The first one is get rid of arbitrary rules. We, as network engineers, are really good at inventing arbitrary rules. So we are coding some random information, not random, but arbitrary, into things like IP addresses and VLAN IDs. Network engineers can even code their shoe sizes into IP addresses. Just kidding. Anyway, in automated world, you don't need lots of those rules. Some are needed, for clarity, but not nearly all. So this is the good point to get rid of them, to keep automation simple. The number 2, follow declarative model. So last year in this conference, I learned the concept of declarative versus imperative models from Roman Dodin. And I think that's covered what it means. But we have a really simple way of achieving declarative model. So when we push configuration to the network devices, we replace entire configuration of the switch or router every time we push. And by doing so, we don't need to think about what's getting deleted and so on. It's up to the device to figure out what to add and what to delete. Also, it's a way of managing the drift. A lot of people are asking us, how do you manage drift? And I'm like, what drift? Every time you push, you override an entire configuration of the device. So our network engineers and network admins, they know that. They know if they need to, if they needed to do manual change, they need to reflect that to the netbox or deal with it somehow. Otherwise, next time, push will override it. Number 3, make models as generic and flexible as possible. So when we started this journey, we tend to make the models quite case-specific and fixed, like hard-coded. Along the way, we learned how to make the models more generic. So, for example, nowadays when we design a service and model for it, we almost always add a template for it as well. So we had virtual network and virtual network templates. We actually have MPLS site and MPLS site template. So this makes it really easy for network admins to add a couple of templates for their different use cases without need to touch to code. With that said, if you haven't already and got inspired, start to explore higher levels of abstraction. And thank you. Any questions?
Hello? Hi. Thank you for your presentation, really good. I see that you guys have worked a lot with the netbox models and plugins. We are also trying to develop some custom plugins, but we have met with the documentation and the examples are really basic, like doing the basic things and really simple stuff. But when you try to do things more complex, how did you solve it? Did you just go into the Django documentation, or how did you find the proper way to creating these models and code for networks?
I would take that step back to just to say that I didn't write that code. So I have very good developers. And I, as a network engineer, realized that really quickly that me learning like to be Python expert won't scale. So my colleague is here who wrote this, and he can answer you.
You can follow my voice. Hey. I wrote my question because it's a bit long, but so hang on. Yeah, so I'm thinking after you create these abstractions, I'm assuming you're then handing them over to operators of the network, engineers or whatnot. My question is, how do you prevent your abstractions from becoming their own networking paradigm? Or is that maybe the goal? So let me give you an example of what I was thinking. So in a cloud environment like Azure, right, they create these abstractions similar to what you did. And then there are certain kind of exceptions or rules that you have to learn in Azure because that's how it works, right? They've created this abstraction. So if you create a VM in a VNet, you can't have it in 2 VNets, for example, for their own reason because of the abstractions. Now, doesn't that become a limitation? How does your operator, are they going to be certified in running your own networking paradigm? Yeah, I feel like the abstraction is good in a way, but in that way it can be a limitation. So I'm interested in hearing your thoughts.
Yeah, so I think what you are asking is that do we agree on all of the abstractions with our network admins? And I have a really strong network background and really strong opinions how to make those abstractions usually. And sometimes there is debate how to do those. But in high level, when we use them, they are actually quite simple. And so far, they have been covering all of our use cases. And then it might be that the network design changes and we need something more, and then we go back to the planning board and modify those abstractions. So we try to make them work as the network is supposed to work, try to model that.
I had a question here, but you already linked to it maybe. How do you deal with updating the abstractions? If you get a new requirement or a new idea of how of making it better, how does this get into the general workflow?
What's the workflow of redesigning or enhancing the abstractions?
Yes.
It's basically the same as coming up with the new ones. We need to understand the need, what is changing. We need to decide, because we can make the abstractions however we want, but not all of the ways are good ones. So we need to decide. And it's the balance between the flexibility and the simplicity. So, but we follow the same process as when creating a new abstractions. There are lots of discussions usually.
Hey, awesome presentation. Thanks ever so much. Love the ninja to diagram stuff, by the way. I encourage everybody else to check it out. I was watching your YouTube video for last night. And totally behind the declarative approach, just as a curiosity, I'm wondering what sort of cadence you're finding where engineers do need to log into the CLI and just make an ad hoc random change, and the degree to which, I don't know, is that still a thing, or are you locking people out of the CLI, I guess is my question.
Sorry, could you repeat a little bit slower?
So I really like the declarative approach, but you referenced that, drift isn't a thing, of course, but you made a remark that engineers who need to log in and make configurations at the CLI will then need, of course, to make adaptations to the orchestration framework. But are people still logging into the CLI, or are you logging them out by design, or not allowing CLI access?
We are not logging them out. They are allowed to go to CLI. They are even allowed to configure things. But they know that if they leave something for their colleagues to handle, that's kind of a really bad thing.
But is that happening? Is it causing additional drama that you're having to solve?
I haven't heard a lot.
One more. Okay, thank you very much.
Thank you.